on your entire cluster. So if you do Docker run, basically it will run on your entire cluster. It's extremely easy to get started. You'll see this because I'm going to go through the setup with you. We're going to set up a Swarm cluster with a console backend. So yeah, and it follows the principle of batteries included but swappable. Basically, before companies were using custom shell scripts to handle the clustering of all their Docker hosts. But now you have something to do this, and Swarm is here for this. You can use it. We don't force you to use it, for example. You can use any of the clustering technologies, but Swarm is a great building block to actually build a fully fledged orchestration tool. And it's really neat to have it because it's better than nothing, right? So yeah. And the fact that it's really easy to get started with, it's easy to set up, is a great thing to note about the system. About the timeline, it's a fairly new project. So it was the first proof of concept was made in October by Victoria and Andrea, and they made an open proposal at the Global Hack Day in November, and they released it. They made it open source at DockerCon EU. And then there was the first release candidate and Swarm beta release around February, and we just released the O2 release in April. And we aim to release the O3 release in June for DockerCon. So it's fairly new. There's a lot of things to do inside the project. So if you want to contribute, just come say hi on IRC and on GitHub, and we'll be pleased to just get you started with the system and with Swarm and how you can contribute on the project. So Swarm O2 just supports a lot more calls of the Docker API. So basically, we aim to support 100% of Docker API commands, but now we support approximately more than 85%. Hopefully, for the O3 release, we will support 100% of the commands. It has resource management. So as I told, you can just have this entire vision about how many resources are available on your cluster. So you can tell, for example, you can specify for a container how many memory you need to use. So you can specify dash memory equal 8 gigs. So your container will use 8 gigs of RAM, for example. And it's aware of networking. So if you're exposing a port inside with the host, if you schedule another container that will use that port, for example, an Apache server or an Nginx that uses like the port 80, you'll just try to find the best machine that has the port available for you. So you don't have to worry about networking and which port are available before doing the Docker run with Swarm. It also has advanced scheduling techniques with constraints and affinities. So we're going to go through all of them. So basically, it's to tell, run my container, but not on machines that are, for example, of this kind. Or you just want, for example, to specify a constraint to tell, I want my machine to run on a Fedora operating system or an Ubuntu operating system. And affinities to tell, for example, I want my container, my web container to run next to my logging container because I want, obviously, to do logs, and they need to be collocated on the same machine. So you can specify an affinity to tell that your logging container needs to be next to your web container. It also has multiple discovery backends. So we're going to see this, that you can use the hub for the discovery backend. So each time your Swarm agent are going to join the cluster, then specify a token. This token is used for each machine to register on the system, and then the manager is going to use that token to retrieve the information back and connect to each of the Docker daemons. But we also support custom like etcd, console, and zookeeper to do this. And for this presentation, we're going to use console because if I use the token, probably that we're going to run into trouble in a public presentation. So I'm not going to use this, but yeah. And we also have support for TLS for encryption and authentication. I mean, if you have few Docker daemons that are with a traffic that goes through the public internet. You probably don't want for everyone to see what's going on. So you have support to set up your own certificates, etc. So we're going through the setup. So this is using the hosted discovery service. As you can see, it's really easy to set up a Swarm cluster. It's just 3 simple commands. At first, you do Swarm create, which will return you a token. So it communicates with the Docker app to create a custom token for you. And then you will use that token on each one of your machines to join the cluster. So to add a node on your cluster, you do a Swarm join, --add the IP of your node, and then you specify the token, and we just register your machine inside the Docker Hub. And then you start Swarm, so you use Swarm manage, and you give the same token, and we'll retrieve all the information and discover all the machines that are inside your cluster, and we'll communicate directly through the Redmond API with them, and just have this entire vision that I told before. But yeah, I've noted that you can also use etcd, Zookeeper, or console to do this. So now let's talk about the Swarm scheduler. It's basically done in 2 steps. So first, you apply filters to exclude nodes. So there's a bunch of filters available, like the port filter. As I told, if the port 80, for example, is not available, you will try to find a machine that has this specific port available for your container to run. Then you have a constraints filter. So basically, when you start a Docker daemon on one specific machine, you can give labels. And those labels can be used to specify constraints. We'll talk about this later also, but if you specify a label, for example, environment equals staging, you can just specify constraint. I want my container to run on the staging environment, and we'll just pick the set of nodes and exclude all the other nodes that are not on the staging environment. Or, for example, production, etc. You also have affinities. So, yeah, that's basically tell a container to run next to another container. Elf, obviously, you have a natural elf filter, so it will not pick all the nodes that are not healthy. So if nodes are down, they will not be chosen for the scheduling part. And the last one is dependency filter. This one is used when you do --link, or when, for example, you do --volumes from, and will pick the node with the actual dependency that you have. If you do --volumes from another container, it will just schedule your container on the same machine on which you have the volume. Oh, sorry. Yeah, and the second step is actually to use a strategy. So on the set of nodes that are left from the filter part, now you apply a strategy on them, and there are 3 kinds of strategies. So bin pack is you say, fill this node before going into another node. So you're trying to pack everything into one node before going into another node for the scheduling part. Spread will just try to spread evenly your containers into your whole cluster. So you do node 1, node 2, node 3, node 1, node 2, node 3, for example, if it has the resources available. And random will just pick a node at random. It's basically, yeah, it's just random. So let's talk about resource management. So you can control how much resources your container use with Swarm by specifying the flag -m or -c. So if you want your container to use 1 gig of RAM, you will specify Docker run -m 1 gig, and Swarm will try to find a machine that has 1 gig of RAM available. Same goes about CPUs and core. So now we specify Docker run -c1, which will try to find a machine with 1 CPU core available. And then same about ports. If you expose the port 80 from the port 80 of the container on the host, it will try to find a machine with the port 80 available. And there's more to come because we have network interfaces coming. You probably heard about a project called Live Network. This project aims to create virtual networks between containers. So this will allow us to link containers between hosts. So you can specify, for example, Docker run dash net equal your virtual network, and I will try to pick the machine with containers, for example, that are on that network. Yeah, so we're going back to constraints. So as you know, when you do Docker info on the machine, you will have a bunch of information. So for example, you will see the operating system, the storage driver that is used, and a bunch of other information. And you can naturally use those informations to specify constraints. So for example, if you do a Docker run -e constraint operating system equal Fedora, it will try to pick a node with Fedora on it. Same if you do about Ubuntu or the example with AUFS, it will try to find a machine with the AUFS driver. And you can apply custom constraints. So you see that docker -t -- level command. When you run first Docker on a host, you can specify a label. And here we specify that our Docker daemon, for example, we have an EC2 instance that is on the US East region, and we specify a region that is on US East with a label. And then we can use, when you do a Docker run, you can use this constraint and tell, I want my container to run on the US East region, or I want my container to run on the US West region. This is pretty useful when you have a distributed cloud setup between multiple regions. Or even if you want to tag, for example, I want to deploy my container on Azure or on GCE, you can just tag and tell constraint cloud equal your specific provider. So that's pretty neat. And you can also do something pretty random. You can pin a container to a specific host. So if you have the name of the host, you can just tell, just schedule that container on node 1 or node 2, because you know that you want this specific node to run that container. So that's okay. And then you have affinities. Affinities are different in the sense that you specify something that you want at runtime. So, for example, when you do a Docker, you first run an Nginx, and then you do a Docker run -e affinity container equal web logger, and Swarm will schedule your logger container to be next to the Nginx container, which is named web. So it will just take the name of the container and will schedule it onto the same machine. And you also have anti-affinities. So it's basically to tell Docker, don't run my container next to this one, because I don't want to, because it doesn't make sense. For example, if I run a Redis master container, I don't want my Redis slave to be next to the Redis master. I want it to be onto another machine. So we specify an affinity to tell, I don't want my container to run next to a Redis container. So just try to find a machine that doesn't have any Redis container on it. And finally, you also have image affinities. So this time it's tell, if you have a bunch of images pulled on a machine, you will tell, run my container Redis on a node which already has the Redis image pulled. And you just save the time of downloading the image. For example, if you have constraint about, I don't know, bandwidth or something like this, you can specify those kind of constraints. New in Swarm 02 is soft affinities. So you can basically tell, try to apply the affinity. So try to not run my container next to another Redis container. But if you don't find any machine that is available and that don't have a Redis container, then do whatever you want and use the default strategy. Just schedule it because I want it to be scheduled anyway. So we had this little tilde in front of Redis to tell, just try to not run my container on a node that has a Redis container. But if you don't find any machine that don't have that image, you can just schedule it somewhere. I don't care. Okay. Now I'm just going to do a quick overview about the integrations. You probably heard about tools like Machine or Docker Compose. So machine is basically to create machines on cloud providers, so that different drivers. You can just tell a machine create on Azure and create a swarm, a cluster. And also compose. So compose is a bit different. You have the .yaml file, and you specify your whole container deployment. So for example, you'll tell your Apache server or your web app linked to a MySQL container, and you just expose port, you do everything, and just do a compose hub, and you don't have anything to do. Compose will just traduce it to the Docker remote API language and run those containers for you, and run all the set of commands sequentially to just have your deployment running, basically. So machine is fully integrated. For now, you can run a Swarm cluster using machine, and Compose is partially integrated. But you can see an awesome presentation from Ben Fishman, which actually uses machine, Compose, and a bunch of tools, which is really amazing. And you can see that how it works and how the set of tools are meant to be used with each other. And last but not least, we plan to have Mesos and DCOS integration. It has started in collaboration with Mesosphere. What you can do is basically use Swarm to do a Docker run, and it will just run onto your Mesos cluster. Swarm will act as a framework, and you will be able to use any tool that talks the remote API language. So yeah, I'm kind of rushing, but because we are going to the demo and have a lot of things to do for the demo, so yeah. So we are just going to, Okay, we're just going to set up a Swarm cluster together. So on the right, you can see my 3 agents, Agent 0, Agent 1, Agent 2. Those are the Swarm agents that are running my Docker daemon and that are exposing this Docker daemon to the network. If you do Docker info, you can see the label applied to those Docker daemons. So here you have one agent that has a regular disk storage, another one which is on the region US East. Then the second one has a storage that is an SSD and is on the region US East too. And the last one has an SSD storage and is on the US West region. So if we go back, it pretty much looks like this. So you have 3 agents, and the first one has a disk and is on US East. The second one has an SSD and is on the US East, and the third one has an SSD and is on the US West. So I want to do an example with chaining constraints. That's why I made this particular setup, so you'll see why. But yeah. So let's set up this cluster. The first thing you need to do is join in the cluster with agents. So we are going to run Swarm. I'm going to clear that screen. Swarm join --addr. I'm specifying the address of the current node. And then I have a console running on another instance, and I'm going to use it for the discovery service. So I'm specifying the address of the console machine running. So if I run this command, Swarm Agent 0 is going to register into the console backend. So yeah, so I forgot, but at the end you need to put a path for console to be used. Okay. So now my first agent is registered to the console backend. We're going to do the same thing for Swarm Agent 1 by changing the address here. Okay. same about the third one. So we have now 3 agents running and registering to the console backend. So they're registering every 25 seconds. So they're just registering periodically to tell the backend I'm alive and I should be considered as being alive. Now we've done this, we just need the manager running, and we're going to use the swarm manage command for that. So you just have to type swarm manage. You're going to expose the swarm API on 4243 on your machine, and use the same address for the console backend. What this command will be doing is the swarm manage daemon will fetch all the information on the console backend with all the addresses of the remote servers, and then try to connect to each of them. So now we have our swarm manager running. We can just pull this off. And if I do a Docker info, I can now see my 3 nodes running. So there is my swarm agent 0 with 4 gigs of RAM and 1 CPU core, my swarm agent 1 with 4 gigs of RAM and 1 CPU core, and yeah, the swarm agent 2 with the same setup. We see that the default strategy used is spread, and we have a bunch of filters that are used, to just eliminate a bunch of machines. So that was pretty easy to configure, right? This was just 2 commands, one for the swarm agent and one for the swarm manager. You don't have anything more to do. It just works right away. So just to show you that it works, we just do docker run busybox equal hi everyone. So you can see on top the events going on and being sent to the remote Docker daemon. The request is being proxied to an agent and being taken care of from an agent. So there is a container create event going through the API. So if we do a docker ps-a, we can see that our container, was running on swarm agent 0. So swarm actually chose that node to run this container. Now let's see that you can use any command of the Docker regular CLI command. So if I do a docker pull Ubuntu, it's going to pull all the images on the 3 nodes. So it might take some while. So, it's done. So yeah, network was in our favor today. Yeah. So it works, and we can do a docker. We can also do a docker run -e-t Ubuntu in bash. And actually, the container runs on a remote host, but you have a shell, and you can do an ls apt-get install whatever, git or something, and it works. You can issue remote commands to a container that is actually running on one of your swarm agents. I'm going to stop that. Okay. So now let's remove and clean everything. We are clear. So I'm now going to make a small example of resource management with Swarm. So we're going to specify how much memory we need to run an Nginx instance. So if I do a docker run -d and I specify with -m that I want 2 gigs of RAM, it doesn't fail because it has the resources available. If we do a docker ps, we see that it's gone to the swarm agent 0. So now let's run it again and see where it goes. So if I do a docker ps, I can see that now it's on swarm agent 2. So it's using the spread strategy. So we just try to spread containers evenly on the cluster. And if I run this one last time, yeah, you can see that there's one container on swarm agent 1, one on swarm agent 2, and the last one on agent 0. Now, let's do something that is not allowed. Let's try to schedule a container with 3 gigs of RAM into this setup. So Swarm just throws me an exception because actually we don't have the resources available on any one of those machines. There's only 4 gigs of RAM on each of those nodes, and they're already running a single container with 2 gigs of RAM. So this is not a regular and an allowed operation for us. But if I remove one of those containers, or for example, I will never remove it, I will just reschedule it. And if I do a 2 gig, then Swarm accepts that command because there is actually 2 gigs of RAM available on each one of those machines. And if I do Docker PS, I can see that we have 2 containers on Swarm agent 2. So now Swarm agent 2 is entirely filled in terms of memory, and we can verify that doing a Docker info. You can see that Swarm agent 2 using 4 gigs from the 4 gigs that are total on the system. Yeah. So again, let's clean that environment. Okay. So, well, now we're going to do something special. I told you about this particular setup. So I want my container to run on the second node, but I want it to be run in a specific way. I want it to run on US East and on machines that have an SSD. So I want the specific set of machines that satisfies the constraint of being on US East and having an SSD as a storage. And to do this, we can just chain constraints. So if I do a docker run -d-d, and I specify the first constraint, equal SSD, so that's my first constraint, and then the second one, so what I'm basically doing is telling Swarm to run my container on a machine that has an SSD storage, and which is on the region US East. But there's only one, right? It's only the Swarm agent 1 that satisfies this constraint. If I run this and I do Docker PS, I can see the container being scheduled on agent 1. And if I do if I run the command again, it's going to fail. Well, it's going to fail because the name is actually used. But if I do this, oh yeah, no, it's okay. Wait, I messed up somehow. Yeah, I used the -- name. Yeah, it's okay because I didn't specify any resources. I actually messed up because I forgot the -m 2 gigs of RAM. I want you to do that example with the resource management. So if I do 2 gigs, let's do 4 gigs. So yeah, it's actually going on the same Swarm agent. I specified 4 gigs. But if I actually specified 2 gigs and I was specifying, for example, 3 gigs, it will throw me an error because the Swarm agent 1 doesn't have the resources available. So yeah, I kind of messed up this example, but you have the point. So let's clean everything. And we're going to do this back to actually show you an example of resource management and chaining constraints. So yeah, I'm going to do this again without failing this time. Okay, so let's run this container. If we do Docker PS, we can see it on Swarm agent 1. That's okay. If we do this again, yeah, okay, Swarm returns us an error because Swarm agent 1 doesn't have the resources available. So, okay, let's drop a constraint. Okay, we don't need the US East region constraint, so we drop it. We just need a storage SSD. So basically, if we run this, it works. And it ends up on the Swarm agent 2 because it's the only one that actually has an SSD storage, and that doesn't satisfy the constraint of being on US East. So, yeah. If we try this again with 3 gigs, it doesn't work because we don't have any machine that has an SSD storage. So we can drop that constraint. And if we do like a PS, the last one will be on Swarm Agent 0, which is the one with a regular disk and without having those kind of constraints. If we try to run this again, just a simple container with no constraint, we have an error because no resources are available. So yeah, this is pretty much flexible. You can just chain constraints. You can just tell I want my container to be on the production environment using an SSD, using being on region East, and being on the cloud Azure. So it's pretty neat to do this and chain constraint this way. So I'm going to stop for the demo part, and I'm going to quickly talk about upcoming features. So we plan to support KV backends for the storage part. So right now, the Swarm Manager is storing the state of the entire cluster locally in a file, but we want this to be handled by a proper storage backend. The reason for this is to achieve high availability and to have the replicate state between multiple managers. I'm going to show the example why this is needed. We also plan to have attempt at rescheduling on node failure. So if one of your Swarm agent fails, all the containers that were on this machine are going to be rescheduled onto another container. And also the networking part, so being able to do links between containers that are on multiple hosts. And this is basically done by lead network. And when the integration with Docker will be done for lead network, we will be able to use it just talking the regular Docker remote API. So let's talk about unfair rescheduling. So when you have a node failure, what you want to do is basically do something like this. It's moving the containers that have failed on one of your nodes and try to reschedule them into other nodes. If it doesn't have the resources available, then we will fail, but at least you need to try, right? To achieve high availability of your system. If you have a web server and you want it to be available no matter what happens inside your cluster, you need that kind of feature to happen. But there's a single problem with this, and this is where the high availability and state replication enters into action. Sorry for being really quick about this, but you will get my point. So in Swarm, we can do this kind of architecture. We can have the Swarm Manager running inside the Swarm agent, on the Swarm agent. So you have the Swarm agent and the manager running inside the same machine. And I think you see this coming from a mile away, but boom, now this node fails. So what happens? There's two bad things happening. We cannot contact the cluster anymore because we don't have any manager running. And actually, the state of those containers is entirely lost. If the machine comes back to life and the disk is live, then it's okay because it will try to reconstruct the state with events from remote Docker daemons and the state that is on the single file in this machine. But if the disk fails, then it's game over. You don't have anything left, and the state of those two containers are lost forever. That's really, really bad, and we absolutely don't want this to happen. So one of the solutions for this is to have this kind of architecture with backup managers. So you have one leader that is actually the master. You talk to this one. But if something bad happens, so if this manager fails, you can pretty much, there's one other backup that will be elected as the leader, and will take away the lead, and you can talk to this one instead. And you don't lose any information because the state is replicated from the manager to all the backups synchronously. So you don't have any information that is lost. So if the disk fails on the first manager, you still have that information back from the other backups. And now if one of your nodes fails, you can obviously rebalance those containers if you have this information. So this is pretty much transparent for you. For example, if you're using a system like console and you're using console DNS, you will just point to a domain name with an healthy server all the time. So each time you will issue a command, it will just talk to an healthy server. So you don't see anything, basically. So I have then 5 minutes to talk about Mesos integration. I'm going to steal Victor's subject. But this is also very important because it's not really obvious why would we need to have this Mesos integration. Because Mesos doesn't talk the Docker language. It has frameworks like Marathon, etc. But we can, for example, use tools like Compose or Fig on top of Mesos. And that's where Swarm integration with Mesos enters into action. If we can put Swarm as a framework between a Mesos and all the other tools from the Docker ecosystem, then we can achieve something like this using a single YAML file with our description for our deployment, and just do a compose up and we talk the regular Docker API language that is like what Swarm is doing, and then having everything running into your Mesos cluster. Yeah, which is pretty neat because actually you cannot do that. You cannot do something like a description of your entire container deployment and run it into this kind of cluster. So this integration will allow something like this. Whew. Okay, so thank you very much. Sorry if I've been like too quick about exposing all those features. That was pretty dense presentation. So if you have any kind of question, you can ask me on social networks and obviously on my email, for example, and also on IRC and GitHub. You can just open issues if there's something you don't understand, etc. And yeah, I'll try to answer your question. Oh, yeah, sorry. Okay. The question is, what are the differences between Swarm and Machine, and where do each make the most sense? So these are two complete different tools. Swarm is really used for clustering and orchestration, and Machine is used to just spawn up Docker machines. So Machines has a set of drivers to run to create a VM on Azure, and it will just launch a Docker daemon inside this. But it has absolutely no knowledge about all the resources inside the cluster. And Machine has a driver and has something to spawn an entire Swarm cluster. So it just launch a given amount of Swarm agent with a manager, and you can talk to this directly. So the setup is done like from A to Z by Machine. But yeah, pretty much it's just the mean to achieve this, but it's not Swarm. Swarm is basically talking the remote Docker API, getting all those information to have the entire state and schedule your container into the right node. Machine is not doing this. It's just spawning VMs and putting Swarm inside this. And yeah, if you want to have a cluster running really quick, you will use Machine for this. And yeah. So when we run a container on Swarm, how to get the real service address and port? The same way you use the regular Docker CLI command. If you do Docker PS, you will see information about here. You see ports exposed. So what I've done here, I will try to get my screen better here. Yeah. So what I've done here to run this Nginx container is running with the -grade P, which tells expose the port 80 inside the container to a random range of port between, I don't know, 30,000 to 65,000, which is like the limit of ports available. And you can see this information just doing simple Docker PS. So you can see this, that the Docker 80 is exposed to the port 32,779, and here you can also see that the port for 43 is assigned to a random port in the host. Okay, is there a link to this presentation? Yeah, I'll try to put it online and probably post it on meetup. That was his question. What's the current state of the API corresponding to everything you demonstrated at the command line, REST client, or only Go right now? It uses a Go library, but it pretty much supports 100% of what is available from the Docker API. We just miss a few commands, like for the authentication, there's some work ongoing with Docker login, for example, because there has been some change with Docker Hub v2. And we want that when you do a swarm create, you just specify your username and password, and you get like your token, not something like public or everything. You get your token, and you can just use this login to probably delete your cluster or manage your cluster yourself. And yeah, there's probably a few other commands that are under work, but yeah. Okay. So this is a long one. How can I assign resources to a particular agent? For example, just agent 1. Basically, Swarm will take all the resources that are available. If you are spinning up a VM with 4 CPU cores and 8 gigs of RAM, Swarm will take all those resources to specify that it's actually agent 1's resources. If you have one VM you can have agents with different kind of resources. It doesn't have to be the same amount of resource. And okay. Sorry. What does KV stand for? It's for key value stores. To have simple operation like put, get, delete. This is for the storage part. So when what we are actually doing in Swarm Manager is storing the state into a local file. But what we want to do is to have it replicated on a bunch of machines. So we want to use something like a distributed KV store. So when you do a put on the master, the value will get replicated on the other backups, so you don't lose the information. But yeah, KV stands for key value and for simple operation like put, get, delete information. Looks like you use background setup. You could use something with machine. Yeah, I could have totally used machine to do this. I mean, I kind of regret it now because I could have done a machine create for the Swarm cluster. That would have been really better as an example. And probably next time I'll do this for sure. I promise. What is the name of the project that connects multiple containers on different nodes? It's a lib network. We need to integrate this into Docker engine, and it will actually be to specify a single virtual network for containers. So when you run your container for the first time, you will tell Docker run dash, for example, nats equal a name for your virtual network. And if you have a second machine that will specify the same network, they will be able to see each other, even though they are on different machines. And yeah, this project is called Lib Network. It has been open source very recently, so you can check it out on GitHub. Station. Okay. Can you explicit how you position your offers versus Kubernetes? I think you got my point when you saw me like setting up the cluster. I don't think it's fair to compare Kubernetes with Mesos or Swarm. They all have a different purpose. To me, Swarm is really, really easy to set up. You have just 2 commands running, and you have your cluster up. And you can issue a lot of commands on this, and you basically have almost the same capabilities that have those other clustering systems. But for example, Mesos is great at data-intensive kind of workloads. So if you have Hadoop cluster and Spark cluster, a lot of people are using Mesos. And for Kubernetes, for example, it's really about this notion of pods and having services and replication controller and exposing microservices. It's great for microservice infrastructure, for example. But the problem with Mesos and Kubernetes is they're kind of difficult to set up, so it's kind of hard for someone that is a newcomer to clustering technologies to use this right away. If you want to roll out a small cluster and just get out. If you want to run a small cluster and have it running very quickly, then using Swarm is probably your best shot for this. And yeah, that's pretty much it. Okay, how do you wait. What happens with services? Yes, I'm trying to figure out one question. C1 is used to. Oh yeah, what happens when Swarm-C1 is used to deploy a container, and what does it refer to? The -C1 is for the CPU core, so it will actually tell your container to use one CPU core running. In my example, I had 3 virtual machines with 1 core each. If I specified something like -C2, it will have failed. Basically, Swarm would tell me you have no resources available for 2 CPU cores to run your container. How we do this Swarm backup versus Swarm master swap via CLI. So for example, in console you have console DNS, and you can actually have always one name pointing to an LP server. So if you're doing an export Docker host, the name of that, the domain name and the port of that particular instance or the domain name, it will always resolve to an Alpha instance. So you don't have to set up anything for this like swap thing. It was just to show that you can actually, a new manager could get elected and be used as a Swarm manager. But there's no like kind of this swap thing. It's just everything is transparent for you if you're using something like console DNS or you can do something like this on your own. Very good question. Can we change a node's label after we join a cluster? Right now, no, you cannot do this. Maybe in some time. I mean, it needs to be merged in Docker Engine. But yeah, you cannot do that actually. You really need to stop the Docker daemon, change the label, and then going back up with that VM. So say how to remove a Swarm node from a cluster really soon. I mean, it's coming 03. We're going to be able to remove the Swarm node from the cluster, and the manager will not ping like crazy into a container that is not yet that is just gone. Oh, can you provide a link to the Ben Fishman presentation? Yeah, I'll do this. I'll put the slides on meetup, and I'll also put the link to the Ben presentation because it's really great. It really shows the interaction between machine, compose, Swarm, and also a bunch of other tools, which is you'll see it's really magic. Yeah. Okay. So I guess we ran out of questions. So thank you, everyone. I hope you enjoyed the presentation. If you have any questions, just don't hesitate and ask me on Twitter, whatever, GitHub. You open an issue, you can talk to us on IRC as well. And I hope you had a great time. I hope to see you on another meetup. And yeah, see you.